not.
I can hear you now, Alexander.
Uh,
I can hear you.
Hello.
Can you?
Alright.
Hi.
It wasn't like it was circling around forever. That's right. Yeah, I had like two questions about the math lab
Two?
and the pre-class passports.
Okay. So let's talk about my math lab first. Did you have a
Uh,
problem finishing the assignment because of technical difficulties?
yeah, it was like saying inconvenience. No,
It
we
was
apologize for the inconvenience. They were like maintenance.
okay. Um, I may do something about that if about the was it the due date that's concerning you?
Yeah, 'cause I was about to um finish it up because I can move on to 7.5 and 7.6, but it wouldn't let me.
Okay. So when was this?
Yesterday.
Okay. Um, was that was their homework actually due yesterday?
Yeah, 11:59.
Hmm. Um, I can check the system they have on their website when their system has problems, and I can look at what's been going on over there, and I may extend the due date on that assignment. Are you able to work a little bit in advance so that you don't run into issues right against the due date?
I could, but like I work a lot. Like I work 40 hours a week.
Hmm.
Yeah.
I might change the due date, the late penalty to be instead of a flat fee of 25%, I might be able to change it to 5% per day. That would probably be better. Um,
Okay.
but I don't know if I can change it once the assignments are in session, meaning that if anybody has started as assignment, certain settings I can't change at that point. But I will see what I can do about that in future assignments. And I'll check what's going on over at the website. I know they're probably experiencing some more than usual technical difficulties. So thank you for sharing that, and I'll follow up about it.
Okay. Thank you.
You're welcome. Your second question was about the pre-class passport.
Yeah, I tried putting it into a single file, but like it wouldn't let me, so I had to do it singly, like all the pictures.
Individual.
Yeah.
Did you successfully upload them into one attempt
Yeah.
in Blackboard? All right. Well, I'll see how
Well,
that works.
not in a single file, but it was all like you have like 18 of them.
Did you get them in order at least?
Yeah.
All right, we'll see how that looks. Now, what were you having trouble with? Was it Word?
For what? For what? Like,
When you were trying to put them into a single file, how were you trying to do it?
oh, putting them in a folder and then uploading the whole thing.
Oh, as a folder. I have a couple videos on Blackboard where I show how to do it into a document so that it'll just upload as like a Word document. Do you have Microsoft Word on your computer?
Yeah.
Okay. When you go to course information in Blackboard, let me go ahead and share my screen so everybody can see this in case anybody's having the same issues. David. Okay. So yeah, if anybody's having problems with, sorry, I'm distracted because I'm trying to share my screen. Hold on one second. All right, you guys should be able to see my screen now. Okay, so if you're having trouble with the passports, let me just show you under course information down below. Under the orientation video, there's two more showing how to deal with your online pre-class passports assignments. The first video is longer because I'm going over everything about the pre-class passports, but towards the end of that video, I explain in detail how to put your pictures into a Word document. And also in the video down below that, how to use Google Docs if you prefer to use Google Docs, if you don't have the Microsoft Office suite on your computer. By the way, if you don't have the Microsoft Office suite on your computer, there is a way to get it free as a student. Although at this time it might be a little harder to figure all that out since everybody's having issues with tech, and I don't know how the help desk is doing with keeping up with that, but I think they're doing pretty well now that they've had a chance to change things so they can handle what's going on. But at any rate, if you have a Gmail account, there's Google Docs. There's probably other ways to do it. I just went over those two main ways. So can you try that for the next one?
Yeah.
Yeah. Okay. All right. Well, I'm glad you shared those concerns. It gave me a chance to address them for other people who may be having the same issues. All right, Alex. Well, if you don't mind, go ahead and mute your mic again. And let's see if anybody else had any questions. That helps a lot. Good, David. Okay. It doesn't look like there are any more questions, and we've got a good amount of people here now, so I can get into the lesson. Now I'm going to try something different today. So let me go over a little bit more housekeeping before we actually start the content. A couple things I want to point out to you is that the class agenda has been updated because I've decided to allow the test to be available for more than just a single day. So you can see on there in the class agenda now where there's more yellow lines. There's ones for the due dates of the pre-class passports, and there's ones for the tests. And for the test 4, for instance, is due before 11:59 on 4/5, April 5th, on a Sunday. But it's available from April 1st. So you've got those 5 days to get it done. I would do it early so that you don't run into technical difficulties. That's the reason I'm making it available for more time. So I don't want you guys to wait till the last minute and then end up having issues. Questions for me about dates before I move on to the next thing? Okay. All right, so what else do we need to talk about? We already talked about the pre-class passport videos. Let's look at the YouTube playlist. When you go to Collaborate Ultra in Blackboard, underneath where the virtual classroom is, if you go a little farther down, you'll see a YouTube playlist that I've posted. And it says there in yellow, this YouTube playlist contains the recordings of our live online sessions. As time allows, recordings will be moved here and edited down, again as time allows. If a recording is not yet in the playlist, check in Collaborate Ultra recordings section. So 2 things. The actual playlist is here, and down below I've shown some screenshots of how you can open up the actual playlist. I mean, if you press play, it'll start playing from the beginning one after another, but you can also click that little drop down menu up here in the upper right hand corner and be able to go to specific videos. And as you can see in there right now, I have the orientation video, the online pre-class passport video using Google Docs. Then I have 7.1, 7.2, and then it skips to 7.5 and 7 in 2 parts. 7.3 and 7.4, I haven't edited those and uploaded them to YouTube yet, but like it says up in yellow, if you don't see a certain section there, it's probably because it's still sitting in the Collaborate virtual classroom. So let me show you again how to see those recordings. When I go to virtual classroom, and I want to see a recorded session, there's the little drop down menu in the upper left hand corner where the black bar is. Go to recordings, And there you can see the day that we went over 7.3 and 7.4. And you can open that and play it. You can, what's nice about recordings is you can skip forward, skip back, pause it, so you can work along and all that. So today we had been scheduled to cover 7.5 and 7.6. Like I just showed you, 7.5 is already part of this YouTube playlist, and that is how we're going to cover 7.5. You can watch that later. In this session, I'm going to go over 7.6 and then take any other remaining homework questions there might be. And I'd like to see how this goes, because this might work better if I can have recorded sessions for you guys and then start to use our online class meeting time more like coaching and answering questions time. That way, if you have a need to spend more time with certain examples and having step by step being able to discuss the problems, then we'll have the opportunity to do that. And I guess there's one last thing I just wanted to make sure you understand about the playlist here is when you play it, it opens up right there in the Blackboard page. However, if you click the little down in the right-hand corner of the video, there's that little box that'll open it up to full screen. And then you can still open the playlist up in the upper right-hand corner so that you can move to different videos as needed. Now, I have the video playing, and I'd like you to tell me if you can hear the video right now. Could I just have each person say, I can hear the video, or I can't hear the video? Latricia can, Alexander can. Can't, Joanna says. No? Okay. That's interesting. Is it, for those of you who can hear it, like Latricia, Alexander, Jordan, is it quiet though? Is it like really low volume? Okay. I just wanted to know how. Hey guys, I just refreshed my page. Are you able to hear me still? Okay, good, Joanna. Thank you. All right, thank you, Kirsten. Yeah, so I was just curious about how those videos come through when I play them on my computer, because I thought maybe we could watch some segments of videos together and I could take questions about the videos. But it doesn't seem like that's going to work too well. Also, the college did acquire Zoom now, so I could start trying to use Zoom if that works better for certain functions. Although I don't want to do that since you guys are used to doing this now. But I may experiment with that a little bit and see. But basically, you can also ask questions by saying, hey, at this time video 7.5 part 2 at 10 seconds or 10 minutes and 2 seconds, you did a step that I didn't understand. Can you explain that more? So there's some potential for being able to just get more specialized help that way. So do you guys have any questions for me right now about the things I've been going over? All right, so then I'll go ahead and I'll start working on 7.6. So again, 7.5 is pre-recorded. It's in the YouTube playlist, which you can find in Collaborate Ultra. So 7.6 is word problems, and we're going to go over those. And in 7.6, I think I need to share my screen again. Hold on. There we go. Okay, so in 7.6, we're doing proportions and problem solving with rational equations. So some of the skills we learned in 7.5 and really all of chapter 7 become necessary for these problems, which are basically just word problems using our skills from chapter 7. So we'll begin with objective 1, solving proportions. It says a ratio is the quotient of two numbers or two quantities. Okay, so just when we're talking about rational expressions, ratio is the root word there, which basically means division or a fraction. That's why they're called rational. They're fractions. The next definition says a rate is a special type of ratio with different kinds of measurement. So think about something like miles per hour, where the miles are divided by the number of hours. Two different kinds of measurement, miles and hours. If two ratios are equal, we say the ratios are in proportion to each other. A proportion is a mathematical statement that two ratios are equal. So proportions are problems, math problems, with one fraction equal to another fraction. So two fractions with an equal sign in between them. That's what we call a proportion. And this example shows us how to write out the relationship between ratios. It says write the statement 12 diamonds is to 15 rubies. So that's the first fraction down there. 12 is to 15. And then it says as 4 diamonds is to 5 rubies. So then you have the second one. So the fact that it's saying 12 diamonds is 15 rubies as is, that's where we have the equals. That's how we know that the proportions are equivalent. And notice that we're making sure that in both fractions we keep the diamonds on top and the rubies in the bottom. Now if you reduce 12 over 15, 12 can be divided by 3 to get 4, and 15 can be divided by 3 to get 5. We know numerically they are in proportion. You can also take 12 divided by 15 and do that in your calculator, and the decimal that you're going to get is the same decimal that you're going to get from doing 4 divided by 5 in your calculator. All right, so when you do this in your calculator, what do you get? You should get 0.8. Yes, thank you, Alexander. I'm glad you're following along. 0.8. And when you do it with 4 divided by 5, you will also get 0.8. Okay, so that's understanding proportions. And now we talk about cross products. Notice that this says if you have two fractions equal to each other, then the cross product will also be equal. So what we're saying is if we multiply A times D, it'll be equal to multiplying B times C. Now we can talk about why this is true, why this works, and when it doesn't work. It works when you have two fractions equal to each other. And that's the only time it works. If you have, just caution here, and I actually went over in the 7.5 part 2 video, I believe. So we're seeing it again. Be careful, because if you were to have two fractions that were multiplied times each other, you should know for sure that that does not work with the cross product. You can't do, I don't know, I've seen students do things like this. So cross multiplication does not work when you're multiplying fractions. It only works when you have two fractions equal to each other that you're trying to solve. With regular fractions, when you're multiplying them, remember that you multiply straight across, numerators to numerators and denominators to denominators. Okay, so with that said, because I feel it needs to be said, that is a common thing that students will mix up cross multiplying. When you're solving a proportion, you can do cross multiplication. Now let's talk about why does it work? Well, if you wanted to solve an equation that has one fraction equal to another fraction, you might think, well, I would like to get rid of my fractions. So let's look at, if I'm trying to get rid of my fractions, how would I do it? Well, I could get rid of the denominator b by multiplying by b over 1 over here. Now I can do that as long as I do the same thing on the other side of the equal sign, keep everything balanced, right? So then that would simplify to AB, whoops, nope, the b's cancel. That's the whole reason I multiplied by b, right? So this cancels to 1. So then on the left I would have A, and on the right I would have CB over D. Now I want to continue canceling my fractions or clearing my fractions. So I want to get rid of this D right here, so I could multiply by D on both sides and cancel them out from that side. So now if I just rewrite everything in alphabetical order, just because I can, it's more comfortable, and then it looks like what's written here, you can see that this is the result. So it's actually faster to go ahead and just cross multiply in scenarios like this. Okay, so here's another example. Find the value of the unknown number n. Now I'm going to go through several examples that just show the cross multiplying happening quickly, and then we're going to get into the word problem. So I'm going to show them already worked out for you, for just kind of showing more of the examples with just numbers in them, but then I'm going to get to ones that I actually write out and work through. So just bear with this for a moment, because I feel like it's faster to look at them already worked out like this and then apply it to word problems. All right, so you can see that there was cross multiplication done here to give us 51n and then 34 times 3. Then just simplifying everything, we end up with 51n equals 102. Divide by both sides by 51, and then simplify, and you get your answer. And then of course we want to plug that back in and make sure it works. We also want to make sure we never get 0 in any denominator when we plug numbers back in. Okay, here looks more complex. Well, I guess not really that much. The only difference is now you have an unknown in the denominator, and these are the types of problems that we actually will be working with. but you treat it the same. You still do cross multiplying. So when you cross multiply this, you get negative 15x. And when you cross multiply here, you get 60 times 2. Then you just simplify and solve as usual. Now, this is the first example that I felt it would be worthwhile to work through the steps together. Notice that we do have one fraction on the left, one fraction bar with a numerator and a denominator, and then another fraction on the other side with a numerator and a denominator. One fraction on the left, one fraction on the right, an equal sign between. So for this, I can cross multiply. So I'll go ahead and cross multiply so that I get 5 times 2x plus 1 on the left and 7 times x minus 3 on the right. Now from here I can simplify. And before I go on, notice that it doesn't matter which way I cross multiply first. Let me show it another way. Let's say instead of going from here to here first, if instead I went from here to here, then I would have 7 times x minus 3 equals, from here to here, 5 times 2x plus 1. Now, even though you have a reverse of the order, an equal sign doesn't have a direction to it. It's not like one of these, right? It stays like even if you flip it over, it still means the same thing. So it's okay, regardless of which side you have your statements on, both of these will work out the same way. So let's go ahead and solve this. So this is a review of previous sections. So first we'll distribute the 5 so that we get 10x plus 5. Then on the right we'll distribute the 7 so that we get 7x minus 21. At this point, both sides of my equal sign are completely simplified. That's what we want. Simplify each side of your equal sign as much as you can, combine like terms, and then start getting all your variables together on one side and all your non-variables, your constants, to the opposite side. So I'm going to subtract 7x. That'll zero it out here. Then all my x's will be on the left. Now you can do this in 2 separate steps, but I like to do them together to save myself some writing and some time. I'm going to also in this step move my constants to the right side so that they're away from where my x's are. So far, if I find 10x and negative 7x, I'll have 3x resulting on the left. But I can also go ahead and subtract 5 from the left so that it'll zero out, and also subtract it from the right to keep it balanced so that I get negative 26 on the right. Then finally, I can divide both sides by 3 to get x all by itself. So I'm undoing multiplication here. The inverse of multiplication is division. So now I have just x on the left equals negative 26 divided by 3. And then you should check your answers. So to check it, just rewrite your original equation, leaving space anywhere that you see an x. Whoops, I'll leave space first and then come back and plug them in. All right, so I'm going to plug in the negative 26 over 3 anywhere that I see an x, and then simplify both sides and make sure they come out to the same thing, because we're really asking the question if they are equal. You can also do this with a calculator where you can make a decimal approximation of this and plug it in on both sides. The only thing is, like with something like negative 26 divided by 3, that's not going to come out to an exact number. It's going to come out to some decimal that keeps on going or repeating. So you can't type it in without writing out the fraction. And you can do this with parentheses. If you have the recommended calculator, you can figure out how to do all this in your calculator, even if you're using the fraction. If you choose to use an approximate decimal, and if someone would just go ahead and divide negative 26 divided by 3 and tell me what you get as a decimal. Is anybody still with me? Hi, Kirsten. Okay, thank you, Alexander. So you see how that decimal, it ends with a 7 there, but it doesn't really end. What it does is it keeps going forever like this. And so when you write it down, yeah, it's repeating exactly. So if you write something like this, and then you go and you plug that in when you're checking, it's not going to come out exactly right. Your two sides will be a little bit different if you plug in that decimal, because it's not exact. And that can still be okay if it's close, it'll get you close, especially the more decimal places you use in your rounded answer. So the more sixes that I put there, when I plug it back in, it's going to give me a better result. Something else too, I just want to say, if you're going to try to do it in your calculator using the exact fraction so that you don't lose any accuracy, that's a good option. But you have to be practiced with your parentheses. So when you're putting this into your calculator, it's going to look, let's just look at what the left side would look like in the calculator. It's going to look like 2, well, first of all, you're going to need parentheses for the numerator, then 2 times parentheses, negative 26 divided by 3, close parentheses for your fraction, continue your numerator plus 1, parentheses again to close off your numerator, and then divide by 7. So you just have to be really good with making sure that you use your parentheses properly, and then you can use your calculator. It's not to say that doing it by hand isn't an option, but it just takes a really long time, and there's a lot of room for mistakes. And if what you're really trying to do is check your answer, this is a more efficient way of doing it. And I also talked about in 7.5's video, I talked about how when you're solving fractions or equations that have fractions, you have to be even more careful to check your answers, because even if you didn't make any mistakes, you can still have an answer that doesn't work when you plug it back in. What I mean by that is, since some of the examples, for instance, like this one, have an x in the denominator somewhere, sometimes certain values that you plug back in will cause your denominator to become 0 and then it's undefined. So we look for making sure that we're not trying to use something that's going to cause an undefined result. So you've got to check your answers one way or another, whether you're going to do all the math out step by hand, or you're going to use a calculator with decimal approximations, or you're going to use a calculator with exact fractions and being careful with your parentheses. One way or another, you cannot skip the step of checking answers. All right, now objective 2, we're going to get into actually doing word problems now. So we have an example here. It says, on a Chamber of Commerce map of Abita Springs, 5 miles corresponds to 2 inches, right? So if you're looking at the map and you measure 2 inches, that would represent 5 miles in real life. How many miles correspond to 7 inches? Okay, so how we write this out is we say, well, they've given us a proportion, or not a proportion, I meant to say a ratio. They've given us a ratio of miles, I'm going to write it out with the units. 5 miles is the same thing as 2 inches. Now, then they've asked for me to come up with another ratio where instead of having 2 inches, we have 7 inches. So I'm going to set up a proportion, and I need to have in the top my miles, and in the bottom my inches. Now, they've given me the 7 inches, but asked how many miles. So I can use X to represent the unknown miles and then solve this proportion. Now that I have my proportions set up with the units, I can simplify it when I'm ready to solve as 5 over 2 equals X over 7. And now it's a proportion, so I can solve it by cross multiplying. So first I have 2 times X, and then 5 times 7. So then, dividing both sides by 2, I get 35 divided by 2 or over 2, and depending on what the directions say, I'll either give that as an exact fraction as my final answer or as an approximate decimal. Now, this is a word problem. So before I put a box around my final answer, I want to make sure I'm answering the word problem. It said how many miles. So my X represents miles. And in my final answer, I want to say that. All right, so questions for me on this? It's pretty straightforward, right? You also should, and I think this might be better as a decimal, since 35 over 2 miles isn't as easy to think about as actually doing the division and representing it as 17.5 miles. Now, another good reason for doing this is because I can think about whether or not my answer makes reasonable amount of sense for the question. It says 5 miles corresponds to 2 inches. How many miles corresponds to 7 inches? All right, well, I had 5 miles for each 2 inches. Now I have 7 inches, which is a good amount more inches. So looking at the answer of 17.5, that doesn't seem too large or too small, and I feel pretty confident about the validity of this answer. Let's do another example. The standard dose, is that how you spell dose? I don't think that's right. I think that's supposed to be D-O-S-E. See, even the publisher has some typos there. So the standard dose of an antibiotic is 3 cc's for every 50 pounds of body weight. At this rate, find the standard dose for a 130-pound woman. All right, so I have cc's and pounds. So I can set that up as 3 cc's over 50, good job, Alexander, 50 pounds. I'll use lbs for pounds. And then I want to set that equal to a second fraction, another ratio with the same units, cc's in the top, lbs in the bottom, and it says find the standard dose for a 130-pound woman. So they've given me the 130 pounds. What's missing is the dose in cc's. So now that I have that written out, I'll just go ahead and simplify it to 3 over 50 equals x over 130. And if you want, you can put over on the side your final answer is B in cc's. Just so you can have in mind what your goal is, that can really help. All right, so we'll go ahead, and since we have a fraction equal to another fraction, we can cross multiply. So I'll do 50x on the left and 3 times 130 on the right. So that should simplify to, let's see, 3 times 100 is 300. 3 times 30 is 90, so it should be 390. And then divide by 50. So x is 390 divided by 50. I can get rid of the zeros and reduce this to basically reducing by a factor of 10. I can write this as 39 over 5. And then 39 over 5, let's see, that would be as a decimal. Half of 30 is 15. Half of 9 would be 4.5. So, oh yeah, why am I saying half? I'm dividing by 5, not by 2. Yeah, 5 goes into 39. The largest thing 5 goes into evenly is 7 times 5 will give me 35. Okay, with a remainder of 4, put on a 0, 5 into 40 is 8. All right, so we have 7.8, and what was it? cc's as a dosage. Right, now what about some geometry applications? Well, hopefully at some point you learned about what a similar triangle is, but you may have forgotten if you haven't done anything with similar triangles in a while. So here's the reminder of what a similar triangle is. It says similar triangles are found in art, engineering, architecture, biology, and chemistry. Two triangles are similar when they have the same shape, but not necessarily the same size. So another way of saying this is that they're in proportion to each other. So here's an example of similar triangles. You can see that the shapes look the same, but just different sizes. So then in proportion, A is proportional to side D, side B is proportional to side E, and side C is proportional to side F. And they've just shown down here how if you take this side and put it as a ratio with this side, you'll get 1/2. Then if you do this side in proportion with this side, small over large, that will reduce to 1/2 as well. And then also this side over this side will also give 1/2. So that's what we mean by similar triangles. All, when you compare the ratios of their corresponding sides, they all give you the same ratio, the same proportion. So let's try a word problem that involves similar triangles. Given that the triangles are similar, find the missing length. Since the triangles are similar, corresponding sides are in proportion. Now, make sure you understand that the only reason we can use a proportion to solve this problem with triangles is that it was given to us that the triangles are similar. You wouldn't want to just always do this with any old pair of triangles. You would have to know up front that they are similar. Sometimes they can even look similar, but unless it's stated that they're similar, you can't assume that. In geometry, you always have to look for some kind of given statement. Otherwise, you would have to measure the sides and try to figure out if they're in proportion, and that would defeat the purpose of this particular problem. So when they say it's similar, we know we can use proportions. Okay, so now they've already placed the triangles on the page in the orientation that shows which sides correspond to which sides. So that's convenient. We don't have to finagle them around. They're already set up like that. And then it's this side that we're trying to solve for. All right, so now let's set it up. So it looks like these two sides should be in proportion. So I'm going to put x over 5, and that should be the same proportion as this side and this side would give me. Now, when I set up my x over 5, I did it so that the smaller triangle was on top. So I want to make sure that I'm careful. So I'm going to be a little bit more specific here as I write this out. This is x of the small triangle and 5 from the large triangle. And now I'm going to set up a proportion for the other two sides and make sure that I put the small side on top of the larger side. So now that I have my proportions set up, I can simplify it down to just the numbers and x, of course. Then cross multiply so that I get 9x equals 30, and then divide each side by 9 so that I get 30 divided by 9. And I guess you would just leave it like that, since with geometry you don't want to have fractions, or I meant to say decimals that are rounded, and I don't think that one's going to round nicely. So with geometry, we want to have the exact answer because the approximation is 3.33 repeating, but this is a better answer because it's exact. All right, now objective 3, solving problems about numbers. So now we're basically doing the same kind of work a lot, but then we're going to get into stuff that's a little bit more interesting. Example 8, the quotient of a number and 9 times its reciprocal is 1. Find the number. Okay, so first we need to understand what a reciprocal is. So remember that a reciprocal of a number is that number flipped over. So if it's a regular number that's not already a fraction, you can put it in fraction form by always just placing it over 1, which makes sense. Reciprocal of n would be 1 over n. All right, so understanding what a reciprocal is helps to understand what we're reading here. Then you also have to know that a quotient means the result of dividing. Okay, so we have to use these vocab words to understand how to set up our equation. So now that we know these words, let's read it again. The quotient of a number and, okay, so whenever you're talking about a number, we can use x. So knowing that we're talking about a quotient of a number and something else, I can use x over whatever that something else is. The something else comes after the word and 9 times its reciprocal. 9 times its reciprocal. 9 times its reciprocal. So its is referring back to x again. So its reciprocal, x's reciprocal, is 1 over 9. Or I meant to say 1 over x. 9 times its reciprocal is 9 over x. So I can write that into the quotient. So that's the quotient of a number and 9 times its reciprocal. Then it says is 1. Is 1. So if it says it is 1, then we use the equal sign and put a 1 on the other side. Is 1. Okay, so this is basically what we just talked about. Now they used n instead of x. Doesn't make a difference what letter you use. A number, some variable, the quotient, division, and 9 times its reciprocal equals 1. Now they wrote it horizontally, but then you can translate it to let's see, writing it the way I had done, n over 9 divided by n equals 1. If you write it like this, then you want to clear the fractions. So you'll multiply both sides of the equal sign by the denominator. So that it cancels from the left, and then you have n on the left and 9 over n on the right. Now you can cross multiply here so that you have n squared equals 9. Now let's set this equal to 0. 9 squared minus 9 equals 0. Then since it's quadratic and it's the difference of squares, I can rewrite this as n squared minus 3 squared so that I can recognize the difference of squares pattern. And set each factor equal to 0 and solve by adding 3 to both sides for this one and subtracting 3 from both sides for the second. So now I have two possible answers, and it's okay in this example for there to be two answers. Sometimes we disregard a negative, say if it's a geometry question where you're looking for a length, or if it's a question about time in which we know we don't ever have negative time. But for a question like this, they just said a number. So both of these seem like they could be the answer. So I would use both as the answer. Now there's a couple of other ways that you could solve this example. So let me show another way. Let's say you had written it out this way. I would still simplify this to n divided by, let's go ahead and multiply that, numerators to numerators, denominators to denominators. So you have 9 divided by n equals 1. Then you can also write n as a fraction. And then you can recall that when you're dividing one fraction by another fraction, you can use the keep, change, flip approach where you keep the first fraction, change to multiplication, and flip or use the reciprocal of your second fraction. Then go ahead and do the multiplication. So you get across the top n squared divided by 9 equals 1. Then you can multiply both by 9 to get rid of the fraction. So you have n squared equals 1 times 9 is 9. And from here, you can do the same thing we did in the previous approach, the way I solved it the first time. You can subtract 9 on each side to set it equal to 0, factor it out using the difference of squares pattern, and then set each factor to 0. But there is another way that you may be aware of from maybe a previous class. We haven't learned this together yet, but some of you know that when you have a perfect square on one side of an equal sign equal a number, you can take the square root of both sides. But I must caution you, if you're going to do this, so many students will make a very fatal mistake when they use this approach, and that's that they will forget to put the plus minus over here. That's a part that is easily forgotten. So the answer should really be n equals plus or minus 3 as we got. Remember, we got n equals positive 3 or n equals negative 3. Well, if you forget to put that plus minus in front, you're going to end up with only one answer when you should have two. So just be very careful. If you're going to go with this, you have to make sure that you remember the plus and minus sign. Now this way that I showed it, this is in line with what we've learned recently, so I prefer it for you guys. But again, at your own risk, if you're going to go ahead and use the square root method, make sure you don't forget that plus minus sign. All right, so questions for me so far? I haven't heard anything in a while. How are we doing on time? We're doing pretty well on time. I'm going to look at the comments and see if I missed anything else. Okay. All right, so let's look at another example then. Let's start looking at problems about work. Now, problems about work have a special way of of setting them up that you have to know. So here's an example to help us put it together. An experienced roofer can roof a house in 26 hours. A beginner needs 39 hours to do the same job. How long will it take if the two roofers work together? So for understanding, we want to always read and reread the problem, but then we have to think about using times for each roofer to complete the job alone to figure out their corresponding work rates in proportion of the job done per hour. So let me say that a different way. If an experienced roofer can roof a house in 26 hours, how much of the roof would they get done in only 1 hour? Well, they would get 26th of the job done in 1 hour if it takes 26 hours to do the whole thing. So that's why you see down here how they've taken the total time in hours for the experienced roofer and then converted it to thinking about it in a different way as how much of the work would get done per hour, meaning for each hour. And then the beginner roofer, same things going on here. It's 39 hours for someone who's a novice to do the job. So that would mean per hour, that person can get 1/39th of the job done. Now, what if they worked together? If they work together, we don't know. That's the question we're trying to answer. So we'll just call it T for time. Now, whatever that time is, working together after 1 hour, this is how much of the job they will have completed. All right, so now that we have things in proportion, we can take our proportions and add up the experienced roofers per hour time and then per hour job, and then add it to the beginner roofers per hour job, and then we know that together that will give us a total of 1/T. So that's why with work problems, this is how you do it. Set it up like that. Now, this is not a proportion. We don't have one fraction on the left and one fraction on the right so that we can just cross multiply. We have two fractions on the left and one fraction on the right. So the problem is over here that we don't have a single fraction. So you could do the addition to make it a single fraction and then cross multiply. Or you can figure out what the LCD is and just multiply that on both sides to cancel out all the denominators in one step. Either way is going to work fine. I'm going to use the LCD. So the LCD, smallest, the least common denominator, the smallest number or expression that all the denominators will go into evenly. So I'm going to break down my denominators to their prime factorization so that I know what's common, what we already have in common. That way I don't use extra. I want to know what we have in common and what we don't have in common to know what's just enough for my LCD. So I'm going to break this down. 26 I can break down as 2 times 13. Those are both prime numbers. And 39 I can break down as 3 times 13. And then t just breaks down to t or 1 times t. So my LCD, I'm going to take what's common first and write that in. Then anything that's uncommon. So basically everything else is uncommon. The 2, the 3, and the t. So my LCD simplifies to, what is that? 6 times 13. See, that would be 6 times 10 is 60, and 6 times 3 is 18, so I think it's 78t. All right, so I'm going to multiply 78t on both sides of my equal sign. Let me write it out. I'm going to write it out step by step. T is getting multiplied on both sides of the equation to keep it balanced. And then on the right side, if I put this over 1 here, on the right side, I'll have just 78t across the top and 1t across the bottom. No big deal. On the left side, remember we have to distribute because we have 2 terms. So then we'll have 78t over 26 plus 78t over 39. Now, these reduce, so sometimes it's better to write these things in their factored form. So let's say I wrote 1 over 26 as 1 over 2 times 13. And 39 as 3 over 13. And let's say that also my LCD was going to be written in factored form. Just going to write it out nicer here. So it's over 1, but then I want to have 2 times 3. Let's do it in colors. 2 times 3 times 13 times t. Now, why I would want to do this is because when I multiply first to 1 over 2 times 13, I can see that the 2's are going to cancel here, and the 13 is going to cancel here. So what's going to be left for that first fraction, or what I'm really doing is rewriting this fraction in reduced form. So what's going to be left over in the top is just 3 times t. Okay, for the second fraction here, that was when I was distributing my LCD over to here. So notice that the 3's cancel out, and the 13 is going to cancel out. So what's going to be left is the 2, oops, and the t. Then on the other side of the equal sign, obviously t's cancel out, so I'll just have 78. So now I have 5t equals 78 divide by 5 on both sides, and then you'll get your time in hours of how long it's going to take the experienced roofer and the beginner roofer to do the job together. So working together, they should get it done in a lot less time, and they do. This seems like a good answer. All right. Questions on how to set it up or any step that I've done here? All right, so if there are no more questions, let's go on to solving problems about distance. Now, in order to solve any problems involving distance, you're going to have to review the distance formula. And you actually know this maybe without realizing it if you've never thought about it. If I'm going to travel, say, 5 miles, and I'm going to be driving at a speed of, say, I don't know, if you're going 5 miles, it's probably a pretty local, let's say about 45 miles per hour. Then you're going to get your total distance of miles. So, or wait a minute, I said that totally messed up. Sorry. Let me start by saying you're going to go, what did I say, 40 miles per hour. That's your speed. So that's your rate. It doesn't always have to be speed, but that's a good example of a rate. And then how much time you're going to be traveling at that speed. So want the time to be the same units of whatever rate you're using. So let's do hours. Let's say we're going to travel for 2 hours. So how many miles distance, how many miles will you have traveled if you're traveling for 2 hours at 40 miles per hour? Well, that's 80 miles, because for every hour you traveled 40 miles. So D equals RT is the distance equals rate times time, and we can use that in questions like this. So let's read this. And I'm going to put a little shade on here just so that we're not overwhelmed by all the information at once. Try that one more time. There we go. All right, the speed of lazy river's current is 5 miles per hour. Okay, so that's a rate. A boat travels 20 miles downstream. That's a distance, right? 20 miles downstream, that's a distance. In the same time as traveling 10 miles upstream. Find the speed of the boat in still water. Find the speed of the boat, that would be a rate. So you're trying to solve for R somehow. Okay, so it says now use the formula. We know we need to use the formula D equals RT because we're talking about distance, rates, and times. And then we can rewrite the formula so that it's solved for t. Now, why you should know to do that? It's not really obvious, but let's look at the rest of this and then I'll break it down. We know that the rate of the boat downstream would be the rate in still water plus the water current and the rate of the boat. So if you can picture yourself going downstream, here's my stream, and its current is going this way. So if we've got a boat and we're headed this direction, then it's going to go faster. The boat is going to travel faster than it would if the current was completely still. So that's why we say the speed of the boat in still water plus the rate of the current when you're going downstream. Downstream means that you're going with the current. Okay. Now, if you're going upstream, it'll be the opposite, right? If you're going upstream, then it's going to fight, current's going to fight against the speed of your boat. So now that the current is running against the direction that you want to go, the rate that you would normally have, if you call it R in still water, it's going to be slowed down. So we're going to take away some speed, subtract the rate of the current. All right, so now we start seeing a kind of a table of sorts that's made here. And you can do this. Distance equals rate times time. If you just start with distance equals rate times time, and you don't think about the fact that time equals distance over rate, you might still be able to get somewhere. And I'm talking about it this way because I don't think it's obvious. I mean, you can memorize it. You can memorize that with problems like this, you want to solve for t and write time as d over r. But I also like to talk about if you didn't have that memorized, could you figure it out by some critical thinking skills and how I personally would do that. So yeah, you can start with distance equals rate times time and make yourself a table. And then you can make yourself two rows, one for downstream and one for upstream. And so let's read the problem and see how things fit in here. The speed of the lazy river's current is 5 miles per hour. A boat travels 20 miles downstream. Oh, so here's the 20 miles downstream that I need for the distance. 20 miles downstream. Find the speed of the boat in still water. Okay, so I need to remember that R is the speed of the boat in still water. And that's what I'm looking for. Now they've told me that when going downstream 20 miles, see what it says? A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. And the time is the same, right? So because it says it's the same time, I'm just going to let T be time, right? And are we doing hours? What are we doing here? 5 miles per hour. Yeah, so it's probably hours. Now, since we're going to travel 20 miles downstream in the same time it takes to go 10 miles upstream, since the time is the same, they're both going to be just T. Okay. Now, what else can I take from here to fill in my table? Find the speed of the boat in still water. I'm just going to read it again. The speed of the lazy river's current is 5 miles per hour. I'm going to put that on here. Speed of current. And they already told me what it is. It's 5 miles per hour. So that's useful. 5 miles per hour. Now I know that when I'm going downstream, the rate of going downstream is going to be the rate of the boat in still water downstream with the current plus the 5 miles per hour. And when I'm going against the current upstream, it's going to be the speed of the boat in still water minus 5 miles per hour. Okay, so now that I know that the time is the same, that gives me a connecting point. It means that I can use the distance and rate of my downstream and set it equal to the distance and rate of my upstream somehow. And the connection is that when we take that formula, let me do this on the side here, time, D equals RT, solve for T by dividing both sides by R, and I get T equals D divided by R. So knowing that, then I can take my distance of 20 miles over my rate of R plus 5. And for this one, I can take my distance of 10 miles and divide it by my rate of R minus 5. And since these times are the same, now I can set those two ratios equal to each other and solve a proportion. So I'm going to take 20, since T is the same, then I'm going to set 20 over R plus 5 equal to 10 over R minus 5 and solve for R. So I cross multiply I'll cross multiply, it doesn't matter which direction I go, so I'll do 20 times r minus 5 equals 10 times r plus 5, and then solve. So I'll simplify first. 20r minus 100 equals 10r plus 50. Now collect all my r's together. Let's see. And all my constants on the opposite side. And get my new equation. 10r equals 150. Then divide both sides by 10 to get r alone. So that I have r equals 15 miles per hour. So the boat travels at a speed of 15 miles per hour in still water. Okay, so let's just summarize what happened here. I'm going to just clone this and clear the ink. Okay, so we knew this problem was about distance, rate, and time, so we knew to use d equals rt. Then we start to, what you should do is start to assign variables. So as things are introduced, like the speed of the lazy river's current, you should start putting that together by writing things like the current equals 5 miles per hour. A boat travels 20 miles downstream, so you could say distance of downstream is 20 miles. Then in the same time is the same upstream and downstream. And then you can write time upstream is equal to time downstream. And whenever you figure out that two things are the same in a problem, when you have two separate sets of information, like we have downstream and stream and upstream, but when you find that any element of the two sets is equal, you should think about how you can use that. So as soon as you see that the time is equal or the same, then you should start thinking about solving d equals rt for t. In other words, get t alone so that you have t is equal to d over r. Because at some point, you're going to be able to come up with a ratio for each set and set them equivalent. Or you can just memorize, but see, not all problems are going to use the same time. It might be the same distance or the same rate. So you kind of want to be thinking about, why should we know to solve this equation for t, and then, be able to solve a proportion that way. If it was a distance problem, would you be able to do the same? If it was a rate problem, would you be able to do the same? Then the key here also is knowing that the R in the D equals RT general formula is not the same as the R you're looking for in your final answer. So sometimes it can help to define what you're looking for differently. Like, let's say maybe instead of using R for the rate of the boat in still water, we could have used B for that, just so that we don't confuse the two R's. Oh, sorry, I'm trying to figure out how to, my finger's too chubby, I think. There we go. Okay. So I could have written it as B plus 5 and B minus 5. Another trick too is if you didn't already realize that you were supposed to, that the 5 was going to be added and subtracted, sometimes you can start by saying something more general, like upstream, you can use C for current and then put B plus C and then B minus C, and then look in the problem to see if the current is actually given, so you can replace it with another number, but this is fine the way it is. Okay, and then using the formula to set up a table. The formula that you're using, just trying to organize all your thoughts this way helps me at least. Let's go on to another problem. Oh, I guess that was the last problem in this section. All right, so what I can do is just pause and see if you guys have any questions from the homework, or if you'd like me to explain one of the earlier examples, if you had like a specific question about how to work it out. I can even, you can even write on the whiteboard if you want to show me something. So if you have the capability to write on your screen, you can write onto a whiteboard and show me, hey, I did it like this, and this is what I got. What did I do wrong? Or would this work the same? Or, we have options here. You can show me your work if you'd like. Hi, Elijah. We talked about that at the beginning of the session, and I'm going to do some investigating and see if I can change any settings in Pearson to allow for, when I look at their website that shows me their system status for the last week, 2 weeks, month, I can see all the times that they've had problems with their website. And if I can look at that and see that there's been a lot of problems, then sometimes I will extend the due dates. So when we discussed it earlier, that's what I was explaining, is that I was going to investigate what kind of issues they've been having and determine if I should extend a due date. Also, I'm going to experiment with changing the settings for the late penalty so that it's a smaller penalty if it's only a little bit late. And I don't know yet if I can change that setting for assignments that people have already started working on. But if I can, I might change it to a penalty of 5% per day rather than 25% all at once as soon as it's late. And that will do a couple things. It'll still give you guys the motivation to get your work done in a timely way, but it'll also give you less of a penalty if you've waited till the last minute and you run into technical difficulties. So the best approach is to work ahead of your due date so that if technical difficulties happen, you can still get your assignment done on time. But we know that sometimes things happen and we have to do it a little closer to the due date. So I'll try to set it up so that if you do have a problem, it won't be as bad of a penalty. Anne asked, did we have to send a picture of the homework because I tried and I don't think it all sent? And there's, oh, I don't know if Anne can hear me anymore. Anne, are you still there? Anne? Okay, I don't know if Anne is still with us. It looks like she is, but there was like a circle with a slash through it by your name, Anne. So if you're watching this in the recorded session, I'm explaining that I don't know if you can hear me right now as this is being recorded, but I'll go ahead and answer your question anyway. You can hear it in the recorded session. And for the benefit of anybody else who missed the beginning of today's session, you'll be able to see what we talked about in the beginning, but also I'll just say to follow up for anyone who came in a little late. We talked about the pre-class passports. What you do is you take pictures, then you open up either Microsoft Word or Google Doc or any other way that you know how to do, and you copy or insert those images or copy and paste them, however you want to do it, into the document in order, and then save that as a document, and you can upload that single file and it'll have all your images in order. And I put videos. So let me remind you where the videos are. They're in Blackboard under course information. I hit the wrong thing. Course information. Scroll down to where I have these videos set up, and you can see there were videos specifically for online pre-class passports. So if you're having difficulty, try that. And now Anne's emailing me. Well, all right, guys. So anything else? Yes, Anne, I did. And this will be in the recorded session, so I'll let you go ahead and look at that later. But I'll just tell you really quick that if you want to know how to do it, the directions for how to make your images go into one document are in both the first video and the second video here in Blackboard course information. I did give you a much answer than that, but let me see if anybody else has any other questions. And if you want to hang around and a little longer after everybody's left and you want to discuss with me one-on-one, we can definitely do that. You can even talk to me through your microphone. You're welcome. Kirsten says, when will the passport be graded? Would you be able to see it if I uploaded a file straight from Google Docs? Kirsten, I believe that you can upload straight from Google Docs. As long as it's in a format that I'm able to open, I should be able to see it. So if it's like a doc or a docx file, which I believe happens both when you do it in Google Docs or if you do it in Microsoft Word, there shouldn't be any problem as long as it's something that's openable. Is there a late penalty for the passports on Blackboard? There is a little penalty, but for this first one, I'll be more lenient about it. So in general, the late policy is 25% on late assignments. If if you had trouble uploading this first time trying to figure it out, um, I'll be more lenient about it. But then from here on out, just make sure you get them done in time. And the only reason I'm changing the other assignments in my math lab, I'm going to try to change it to a 5% per day rather than the flat fee of 25%. The reason I would do that is because of the site having problems that might be more prevalent right now with all the increased traffic. You're welcome. Anybody else have questions, housekeeping questions? Okay, so let me close the session by saying that we will meet again on Wednesday morning. And if you have specific questions that you want to work out during that session, that's totally doable. Like I said, there's a whiteboard option that you can try to write on if you have that capability from your device. You can also type a problem into the comments bar, or the best way is to click Ask My Instructor in advance. So if you're working on an assignment and you find a question that you want me to go over in the live session, you can click Ask My Instructor, and that'll send right to my inbox. Then I can copy it into my whiteboard and have it all ready to go so we can work on that during our live sessions. I'll try to record another session that you can watch before we meet again. I don't know if I'll actually have time, but don't forget about 7.5. 7.5 I recorded yesterday and posted it in that YouTube video. So if you did come in late, please make sure you watch the beginning. I talked about a lot of important things there. And yeah, make sure you ask questions if you have them. I really want to see you guys succeed, and this is a weird time, but I'm here to help you. So if there's anything else, go ahead and let me know. Otherwise, we can close session, and I'll see you on Wednesday morning. Take care, everybody. Kirsten, like I said, for this time, I'm being more lenient because I know you guys are trying to get this figured out. Just in future, I would expect you to know how to do it the right way the first time. And if it's something like a format issue, um, you know, I can deal with it on a case-by-case basis, but I'll just say a blanket statement in general. Just try to make sure you have it uploaded. That way we don't have to deal with anything weird on the side. But, if you try to upload something from, what you can do? You can also put a note to me when you're uploading it if you're concerned about the format. You can put a note to me just saying it looked like it should be fine, but if it's not, please, let me know. Or, we're just trying to do the best we can in this situation. So be communicative. That's always a good thing. Sure, you're welcome. Net, thank you.